March 17th as 1943. 2.14 hours. The North Atlantic in the Black Pit. The air is so cold it burns the lungs. Third Officer David Chalmers, his face wrapped in a frozen balaclava, clings to the bridge wing of the SS Fort Bellingham. His ship, a brand new 10,000-ton cargo vessel, is wallowing in the heavy swell. All around him is the convoy. 90 ships, a city of steel carrying tanks, bullets, fuel, and food. A lifeline, and they are being hunted. Ping. The faint metallic echo of the nearest corvette's ASDIC pulses through the water. It is a lonely searching sound. Ping. Ping. Starboard bow. Sir. The lookout's voice is a raw croak. White water. Corralmer's stomach drops. He doesn't even have time to raise his binoculars. A phosphorescent torpedo track. A white scar in the black water is racing past their bow. It isn't for them. It is aimed at the ship in the next column. A flash, a column of fire and water erupts. A volcano in the middle of the ocean. The sound, a deep, gut-punching, arrives a second later. The ship in column 8, an oil tanker, is gone. Not sinking. Gone. Vaporized. Hard to starboard. The captain screams. But Chalmers already spinning the wheel. Another explosion. This time closer. This is the Battle of the Atlantic. It is not a battle of heroes. It is a battle of mathematics, a tonnage war. And in the spring of 1943, Britain is losing. Thousands of miles away in a steam-heated office in Ottawa, Clarence Decatur, CD. How Canada's Minister of Everything stares at a ledger. The numbers are not in dollars, they are in tons. The ledger is bleeding. March 1943, 627,000 tons of Allied shipping sunk. Total for the last 3 months, over 1.5 million tons. The wolf packs of Carl Dunett's U-boat fleet are sinking ships faster than every Allied shipyard on Earth. In Britain, the United States and Canada build them. Britain is 6 weeks from starvation. The entire war effort from the tanks in the desert to the bombers in England is grinding to a halt. It all runs on one thing. Cargo. How? An American-born engineer who sees problems not as barriers, but as things to be broken knows the solution. It is not more corvettes. Though Canada is building those, it is not more planes. Though Canada is building those, too. It is ships. Ugly, cheap, slow, and expendable. Ships, ships, and more ships. The American Liberty Ship Program is in full swing. Canada must have its own. The Park Ship Program is born. A fleet of 10,000-ton cargo vessels. The Canadian equivalent of the Liberty, named after Canada's national parks. But there is a problem. You cannot build a 10,000-ton ship without a shipyard. How's gaze falls on a map of Canada. The existing yards are full in Vancouver. The Bar Dry Dock is launching a ship every few days on the St. Lawrence. United Shipyards is a sea of welding sparks and steel plate. The yards in Halifax and St. John are choked with repair work from limping, torpedo-scarred survivors. Every coastal slipway is occupied. Every skilled welder is working. The coasts are at 1,000% capacity, and it is not enough. His gaze moves from the coasts. It moves inland, past the Great Lakes. They too are building ships. He keeps going west past the forests of Ontario and into the vast, flat, frozen emptiness of the Canadian prairies. A land of wheat, cattle, and sky. A landlocked ocean of grass hundreds of miles from the nearest salt water. A senior naval architect from Montreal brought in to consult. Looks at Howe's map. Minister, the man says, his voice thick with skepticism. You cannot be serious. We are building ships, not tractors. You cannot build a shipyard in a wheat field. CD Howe taps the map. He points to cities like Calgary, Edmonton, and Saskatoon. Cities closer to the Rocky Mountains than to any ocean. We can, Howe says, his voice flat. And we will. If the workers can't come to the coast, the work will go to the workers. Get me the president of the CPR. The idea is not just ambitious. It is by every law of logistics and engineering impossible. December 9th, 1943. 0715 hours. Calgary, Alberta. The temperature is 22 degrees. Below zero. The wind, a scalpel of pure ice howling off the Rocky Mountains, is sharp enough to cut exposed steel. The air, 800 m from the nearest ocean, is thin and dry. The ground is frozen iron covered in 2 feet of snow. This is cattle country. This is wheat country. It is absolutely unequivocally not shipbuilding country. But inside the Ogden shops of the Canadian Pacific Railway, the air is 110 degrees. It smells of ozone, hot metal, cold smoke, and a revolution. The Ogden shops are a cavernous city of brick and steel, a complex so vast it has its own post office. For 40 years, its purpose was singular: to be the iron hospital for the CPR's mighty steam locomotives. This is where 200-ton engines were torn down and rebuilt by men whose craft was a black art of steam, grease, and forged steel. Today, it is building something else. Elsie McGregor, 22 years old, pulls her welding mask down. The heavy leather protects her face not just from the arc, but from the searing heat of the preheated steel plate in front of her 6 months ago. She was a farm girl from near Red Deer. Her hands calloused from hauling grain sacks. Now they are calloused from holding a 20-pound welding rod. She presses the trigger. A blinding 10,000-ampere white-blue light erupts in the air, screams, as the arc vaporizes the metal, stitching two massive plates together. Elsie is not welding a tractor. She's not repairing a locomotive. She is welding the bulkhead, the interior dividing wall of a 10,000-ton Parcas cargo ship. This is C.D. Howe's impossible idea made manifest. He knew the coasts were full, but he also knew that Canada, unique in the world, had two massive transcontinental railway networks. The Canadian Pacific and the Canadian National. These railways were not just tracks. They were industrial empires. They had shops. They had massive foundries, 10,000-ton hydraulic presses, 100-ton overhead cranes, and most importantly, they had the engineers. They had men who understood how to tame steel on a colossal scale. Howe went not just to the railways, but to the bridge builders. The Dominion Bridge Company, whose plants in Edmonton, Calgary, and Winnipeg had built the steel skeletons for the Prairie's bridges and grain elevators. The order was simple and insane. Stop building bridges. You're now building ships. The challenge was monumental. A naval architect from Montreal sent to the Dominion Bridge plant in Edmonton unrolled his blueprints. The plant manager, a man named Angus McTavish, looked at the drawings. "What in God's name is this?" McTavish said, pointing to a curve on the blueprint. "That," the architect said, "is the shear line of the hull." "The shear line?" McTavish scoffed. "Son, I build bridges. We use right angles, God's angles. This is a fish." But C.D. Howe's ministry didn't take no for an answer. The ship design was simplified. The famous Liberty and Park ships were designed to be ugly. They were designed to be welded, not riveted. They were designed to be built in pieces. This was the genius of the plan. Prefabrication. You don't build a shipyard in a wheat field. You use a bridge factory to build the whole sections. You use a locomotive shop to build the engines. And so the great retooling began in Saskatoon. A plant that once made road graders is now forging rudder posts. In Edmonton, the Dominion Bridge Company is taking Elsie's bulkheads and welding them into massive 50-ton sections of a ship's hull. These sections, called assemblies, are the size of a two-story house. In the Ogden shops, the boilermakers, men who spent their lives building the complex, high-pressure hearts of locomotives, are now building the triple-expansion marine steam engines for the Park ships. These are not simple engines. They are 13 t tall, 100-ton giants of cast steel and brass. The workforce is the other miracle. The skilled men are gone. They are in England, in Italy, in the Navy. So, Canada turns to its Rosie the Riveters. Elsie McGregor is one of 20,000 women who have flooded into these heavy industries. They are trained in 6-week crash courses. The old-time railway men, the Garrity men, are skeptical. You can't teach a girl to weld. An old Ogden foreman grumbles. 2 weeks later, he watches Elsie run a perfect 40-foot vertical bead. "Well," he mutters, "maybe that one." The prairies are transformed. The quiet agricultural flatlands become a hidden vital organ of the Allied war machine. The work is brutal. It is loud, hot, and dangerous. A drop plate will crush a man. A faulty weld will doom a ship. The pressure is relentless. Every radio in the workshop broadcasts the news from the BBC. Convoy ONS 154. 14 ships lost. 14 ships. That is 140,000 tons. The foreman chalks the number on a blackboard. The welders don't stop. They know their math. The SS Fort Bellingham, torpedoed in Section 1, was carrying 9,000 tons of Canadian-made tanks and shells. Its replacement is the steel in front of them. By January 1944, The system is at full throttle. The impossible is now routine. A massive 20-ton stern frame, the backbone of a ship, is cast in a Winnipeg foundry. A 112-ton main engine is assembled in Calgary. A 50-ton hull section is welded in an open field in Edmonton. The welders working in a blizzard protected only by canvas tarps. But this has created a new problem. Angus McTavish, the bridge builder, stands in the Edmonton yard. He looks at his creation. It is a 40 ft wide, 30 ft high, 50-ton section of a ship's hull. It is painted in rust-proof primer. It is a masterpiece of Prairie engineering. It is also 1,200 miles from the nearest shipyard in Vancouver, and it has to get there. All right, Angus. The CPR man slaps him on the back. You built it now. How the hell are you going to move it? February 10th, 1944. 4 is our CPR Alethard Calgary. Ian Sticks Riley, the Canadian Pacific's chief route engineer for the Western Division, is a man who deals in a world of unforgiving solid-state mathematics. His enemies are rock, steel, and gravity. And tonight, he is staring at a monster of his own creation. The temperature is 30 below zero. The yard is a frozen blue-white landscape under arc lights. The air is so cold the steam from the engine's boiler freezes as it hits the air, falling as a fine sparkling dust. Sticks's is looking at Special Consist 77. It is not a train. It is a 10,000-ton ship deconstructed and laid bare. A steel serpent 110 cars long. This is the answer to Angus McTavish's problem. This is how you move the impossible. For 3 months, Riley and his team had lived in a drafting room arguing with naval architects from Montreal. The architects, in their East Coast ignorance, had sent blueprints. Riley had sent them back, covered in red ink. Your shear line is 18 feet 2 inches wide. His furious telegram read, the Carnot Tunnel is 17 feet 9 inches. Are you building a ship, or are you trying to rebor a mountain? Fix it. The entire Park ship prefabrication program was a war of inches. Now in the Alith yard, the results are ready. On a depressed center well car, a 112-ton triple expansion steam engine built in the Ogden shops is chained down by steel cables as thick as a man's arm. It is the heart of a ship, and it is 800 m from the sea. Behind it, on a series of reinforced flat cars, is the ship's skeleton, the double bottom keel sections, the massive transverse bulkheads, L.C. McGregor's handiwork, and the 50-ton on DB 4 hull assemblies from Edmonton. They are colossal curved pieces of steel overhanging the flat cars by 4 feet on each side. This is a wide load on a scale that defies all railway logic. She's all yours. Sticks, the yardmaster says, handing him the manifest. Riley is not riding the engine. He is the train captain. His place is in a special cup, halfway down the train where he can see both ends. This train is too valuable to trust to a single engineer. It is a national asset. Its loss would be the equivalent of losing a battle. 2 at the front, 1 at the back. Riley orders. 2 massive 2,104 cell-type locomotives, the most powerful steam engines on Earth, are at the head. A third is coupled to the caboose as a pusher. This is not for speed. It is for control. The train's maximum speed is 15 miles per hour. Clang, clang. With a groan that seems to shake the entire city, the 12,000-ton steel snake begins to move. It crawls west out of the frozen prairie, past the grain elevators, past the silent cattle farms. The first 400 m are the easy part. It is flat. Then the train reaches the mountains. The journey from Calgary to Vancouver is not a route. It is an obstacle course. It is the CPR's main line, the artery of the Canadian War in the Pacific and Styx. Riley is about to plug it. The first test, the high trestles. The train eases onto the Stony Creek Bridge, a delicatelle-looking spiderweb of steel 300 feet above a frozen gorge. The bridge, built for 1905-era trains, is now holding the weight of a warship. The entire structure groans in the cold. Riley is in his cupola, his eyes not on the view, but on the load tension gauges on the flat car in front of him. If a chain snaps, if a 50-ton section shifts, but the real test is rock. The real test is the tunnels at Field, British Columbia. The train stops at the base of the Kicking Horse Pass. This is the big hill. This is where the railway enters the legendary spiral tunnels. Walk through, Riley orders. Men jump from the train. Gondani dancers, track walkers, and engineers. They carry lanterns and measuring sticks. The train will move at 1 mile an hour. The men will walk beside it, inside the smoke-filled, pitch-black tunnel. Easy, driver. Easy. The 20-ton hull section, painted in rust-red primer, enters the tunnel mouth. The clearance is 4 inches. The men walk beside it, their lanterns held high. They are listening. They are listening for the sound of screech. The high, terrifying sound of steel clipping rock inside the tunnel. The smoke is so thick you cannot see your own hands. The sound of the 3 locomotives, 2 pulling, 1 pushing, is a deafening percussive roar that echoes off the rock. It is the sound of a ship being born inside a mountain. "Sir, stop!" Riley screams. The brakes lock. The entire train shudders. The couplings slamming into each other with the sound of cannon fire. Silence. Only the hiss of steam. What was it? A track walker stumbles out of the smoke, his face black. It's the B4 section. A rivet head. A single bloody rivet head is catching the rock face. The train is stuck. It is blocking the main line. In 4 hours, a high-priority troop train is due. Riley grabs a sledgehammer and a cutting torch. "We're not going back," he snarls. "Get that bloody rivet for 20 minutes. In the choking blackness, a crew cuts, hammers, and grinds the single protruding rivet head off the hull plate. "Move her." The train lurches forward. This time there is only the sound of the engine. It clears for 2 more days. This is the routine. A 200-mile journey that is fought inch by inch. February 14th, 1944, North Vancouver, British Columbia. Frank McDougall is a salty, a coastal ship, right born and bred. He has built ships, real ships in the Barrow dry docks since 1920. He is a riveter, an artist of steel, and he thinks this whole Prairie scheme is the stupidest idea he has ever heard. What's a farmer from Saskatoon know about a keel? He grumbles, spitting tobacco juice. It's a joke. They'll send us scrap, and we'll have to fix it. Train's here. "Frank," a young apprentice says. Frank walks over to the assembly yard. The yard is vast, a sea of mud and steel. A CPR engine is pushing the steel snake onto the siding. Frank stops. His tobacco chew hangs forgotten in his mouth. He is not looking at scrap. He is looking at a 112-ton fully assembled marine engine, glistening with oil ready to be lowered into a hole. He is looking at a 50-ton bulkhead so perfectly welded a child could not find a floor. He sees the chalk marks still visible. Okay, E. McGregor Ogden shops. He sees a 10,000-ton ship delivered in pieces like a model kit from an engineering god. The train covered in the dust of the prairies, the snow of the Rockies, and the soot of the tunnels has arrived. "My God," Frank whispers. "The farmers, they actually did it." The apprentice looks at the field of steel. It is the biggest, most complicated jigsaw puzzle in the world. "That's great, Frank," the apprentice says, his voice full of a new terrifying awe. "But how do we put it together?" February 15th, 1944. Child hours, Slipway 7. Bar Dry Dock, North Vancouver. Frank McDougall stands in the ring, a piece of chalk in his hand, staring at a forest of steel. The steel snake from the prairies has been unloaded. The yard is now a giant's model kit, pieces scattered in a sea of mud and welding cable. The apprentice's question hangs in the air. How do we put it together like any other bloody ship? Frank growls, but he knows it's a lie. One piece at a time. Get the cranes high above. A whistle shrieks. A 100-ton leveling crane. Its boom reaching 200 feet groans as it lifts the first piece. A 60-ton double-bottom keel section fabricated in Vancouver. This is the spine. It is lowered onto the greased slipway. The massive wooden blocks that will hold the ship until it's ready to taste water. "All right," Frank yells to the crane operator, a woman barely 23. "Give me the Prairie bit, the B4 bulkhead." The crane moves, its hook, descending onto the massive rust-red wall of steel built by Elsie McGregor in Calgary, the one that still bears her chalk mark. It lifts. The 50-ton piece the size of a house swings into the air, blotting out the gray Vancouver sky. This is the moment of truth. It is a moment of impossible mathematics. Will a piece of steel welded by a farm girl 800 m away in a locomotive shop fit a piece of steel forged by a salty shipwright on the Pacific coast? The bulkhead is lowered. It descends slow inch by inch. Frank is on the slipway, his hands up guiding it. Easy, easy, left a bit. That's it. Clang. The 50-ton section lands on the keel. The pre-drilled bolt holes align. The guide pins slide in. It fits. It fits perfectly. Frank McDougal runs his hand along the seam. The weld run by a girl in landlocked Alberta is as clean as any he's ever seen. His skepticism, the coastal arrogance, evaporates. It is replaced by a cold, sudden awe. They did it, he mutters to his apprentice. The farmers, they bloody well did it. Now the factory begins. This is not shipbuilding. It is assembly. A whistle blows. A swarm of workers. 17,000 of them cover the slipway, and more than 3,000 of them are women. They are welders, burners, riveters, and riggers. They clamber over the steel skeleton, their welding arcs lighting up the rain-swept yard like a continuous man-made lightning storm. The ship grows at a visible rate. The impossible parts of the ship, the complex curved bow and the sculpted stern, are built here in Vancouver. They are the bread of the sandwich. The entire 400 feet mid-body, the cargo holds the bulkheads. That is the meat from the prairies. Frank directs the cranes. Get the Edmonton section. Marry it to the Calgary one. Welders, stitch it up. The noise is a physical assault. It is a 247 symphony of hell. The rat-tat of rivet guns stitching the deck plates. The heeze as of 10,000 ampere welding rods. The screech of steel on steel and the constant deafening clang as another 50-ton piece of Alberto is slammed into place. Then comes the heart. The crane lifts the 112-ton triple expansion steam engine. The monster from the Ogden shops. It is lowered slowly deep into the open-topped hull. It must align with the engine mount beds which were laid by Frank's team just last week. Sticks. Riley, the train engineer, is here to watch. He has a bet with Frank. The engine descends. Frank is in the hull shouting an inch. An inch to port. Hold lower. The engine settles onto its mounts. The 40 massive 4 inches thick anchor bolts slide home. A perfect fit. Riley claps Frank on the back. A farmer's work, eh? Frank. Frank just shakes his head, a small grin on his face. The ship is assembled like a car. The hull is stitched up. The deck houses, also built in pieces, are dropped on top. The funnel is lowered. The masts are stepped. In just 58 days, a time that would have been considered a lunatic fantasy in 1939, the ship is done. April 19, 1944. 14 hours the launching. The yard is quiet. For the first time in 2 months, the SS Fort Edmonton looms over them, gray and massive. Elsie McGregor, the welder from Calgary, has been flown out for this. It is her first time seeing the ocean. She stands with Frank McDougal, the shipwright, at the bow. She's big, Elsie says, her voice small, overwhelmed by the scale, by the smell of salt and diesel. Frank says, and she's yours as much as ours. Les, look. He points to a bulkhead, just visible deep inside. Her chalk mark is still there. A siren wails. The shipyard president's wife smashes a bottle of champagne on the bow. I christened the SS Fort Edmonton. Frank takes an axe. Cut the ribbon. With a thack, the final steel cable is severed. There is a groan, a sound of 10,000 tons of steel shifting on 50 tons of grease. The ship begins to move slowly, then faster. It slides backward down the slipway. A controlled avalanche of steel. It hits the water of the Burrard Inlet with a splash that sends a wave across the harbor. A horn bellows. The Fort Edmonton, a ship built in a wheat field, a ship born in a mountain tunnel, a ship stitched together in the rain, is afloat. It is the backbone of the Atlantic convoy. It is the war winner. And 399 more just like it are right behind it, coming down the steel snake from the impossible Prairie shipyards. June 10, 1944. Fives are ours. English Channel off Juno Beach. The SS Fort Edmonton is wallowing, not in the North Atlantic swell, but in the shallow, choppy waters off the coast of Normandy. The air is thick with the smell of cordite and diesel smoke. Third Officer David Chalmers, who survived the Black Pit of 1943, stands on her bridge. His old ship, the Fort Bellingham, was lost. This is his new ship, a Park class, a Prairie ship. He can see the coast of France. He can hear the thunder of the main battery guns from the battleships Warp Spite and Rammels. And all around him, as far as he can see, is the largest fleet ever assembled, and the bulk of it, his cargo ships. He looks at the ship next to him, the SS Fort Garry, unloading tanks onto a Rhino barge. It was built in Vancouver from components forged in Winnipeg. The ship behind him, the SS Fort St. James, is a Victory type. its hull plates welded in Edmonton. This is the end of the tonnage war. The mathematics have been broken, and not by Hubert. They were broken by Side how they were broken by Styx. Riley. They were broken by Frank McDougall, and they were broken by Elsie McGregor, the 22-year-old welder from Red Deer. When the U-boat wolf packs had swarmed in 1943, Allied shipping was in deficit. By the time of D-Day, it was in massive surplus. The shipyards were launching vessels faster than Dunit's as U-boat could even find them, let alone sink them. The impossible Prairie shipyards were a key part of this miracle. They were a feat of logistics, engineering, and sheer stubborn Canadian will. A program that took farmers, welders, bridge builders, and railway men, all separated by 1,000 miles of rock and prairie, and united them in a single continent-spanning assembly line. In total, Canadian yards would build over 400 park and fort ships. They would carry the tanks that liberated France. They would carry the wheat that fed a starving Britain. They would carry the lumber that rebuilt the bombed-out cities. They were the backbone, the ugly, slow, expendable, and utterly war-winning lifeline on the bridge of the Fort Edmonton. Charis gets the signal. Begin unloading. He looks at the brass builder's plate affixed to the bulkhead. It reads Bureau Dry Dock Co., Ltd. Vancouver, Hull Nump 94 Engine Canadian Pacific Railway Ogden Shops Calgary. He has no idea where Ogden is, he just knows that it's the reason he is safe, it's the reason he is here, and it's the reason they are going to.